So I'd like to just give you a couple of some common summations that you can do, that you may encounter. So, and just some formulas for them. So here's a common one. Say summation k goes from 1 to n over k. So what does that look like? That looks like, well, when k is equal to 1, it's 1. When k is equal to 2, it's 2. So you're summing over all of the numbers from 1 to n. And there's a formula for this. This is equal to n plus 1 times n divided by 2. So that's divided by 2. And the idea, it's actually not too bad to see why it's true. You can prove it using induction. But the idea is simply that if you paired up the bookends, n plus 1 gives you n plus 1. And then if you pair up the next number over here is 2, and the next bookend is n minus 1, but 2 plus n minus 1 gives you n plus 1. So each of these blue things gives you a copy of n plus 1. So each of these gives you a contribution of n plus 1. And how many contributions you end up getting? You end up getting n over 2 of them. Now that's literally a proof when n is even, but then you have to argue or show when n is odd. And then it's the same idea, because you have the formula when n is equal to even, and then you just add in the next term after it. Anyways, I won't prove them for you. You can do that as an exercise if you'd like. So that's an important formula for you to memorize. So I'll just rewrite it. So, no, I won't. Okay, here's another important formula, that summation k goes from 1 to n. Now if you're summing over squares, so what does that look like? That's like 1 squared plus 2 squared plus 3 squared plus up to n squared. That's what that looks like. There's a nice formula for that. The formula for that is n times n plus 1 times 2n plus 1 all divided by 6. And there's one more. If you sum over cubes, so it's like 1 cubed plus 2 cubed plus 3 cubed plus, you stop when you get to n cubed. And that is equal to n times n plus 1, or n squared, n plus 1 squared, all divided by 4. So these are common summations. And the idea of proving them is to prove them, you use induction. So to prove these, in general, use what's called induction. So you first show it's true for like when n is equal to 2, and then you argue that, oh, if the formula works up until a given value of n, then does it work for one additional value of n, namely n plus 1. So it's to use something called induction. But you can prove these